to Integers Part 2. Last class we discussed what are integers, representing integers on number line, addition and subtraction rules of integers, etc. Today we will discuss some properties of integers. As like addition and subtraction of integers, multiplication and division also have some properties. If we multiply two integers having the same sign, if both integers are positive or both integers are negative, what is the answer sign we can discuss now. Look, if both integers are positive, positive into positive, the answer sign will be negative into negative is also positive. Look, positive into positive is positive and negative into negative is positive. If we multiply two integers of different sign, that is, if one is positive and other is negative, look, what is the sign? Positive into negative or negative into positive. The answer sign will be negative. Negative into positive is also negative. Once again, positive into positive is positive. Negative into negative is positive. Positive into negative is negative. Negative into positive is negative. The same rule is for division also. Look, a positive integer divided by a positive integer, the answer will be positive. A negative integer divided by a negative integer, that also the answer will be a positive integer. Again, a positive integer divided by a negative integer, the answer is negative. The reverse, a negative integer divided by a positive integer, that also negative. Look, this is the multiplication rule and this is the division rule. Positive into positive, positive. Negative into negative, positive. Positive into negative, negative. Negative into positive, negative. For division, positive divided by positive, positive. Negative divided by negative, positive. Positive divided by negative, it is negative. Negative divided by positive, negative. Now we can discuss what is closure property of integers. Closure property of whole numbers we have studied in class 6. So first let us do the closure property for addition of integers. That is, we can check if A and B are two integers, then A plus B is an integer or not. Let's do some examples and check. Here look, all the answers are also integers. Here 1 is an integer, 2 is an integer, 0 is also an integer. So closure property satisfies for addition. Now let's look whether the same happens for subtraction also. That is, if we have two integers, A and B, let us check whether A minus B is also an integer with examples. So look, 2 minus 0. 2 is an integer, 0 is also an integer. 2 minus 0, the answer is 2. 2, the answer is also an integer. The second one, negative 3 minus 5. The answer is negative 8. This is also an integer. 8 minus 4. The answer is 4. This is also an integer. So closure property satisfies for subtraction also. Next, we can look for multiplication. That is, if we have two integers a and b, let us check whether a multiplied by b is also an integer using some examples. Look, here are some examples. Negative 5 into 2. The answer is, now we studied that a negative integer into a positive integer, the answer will be negative 5 into 2, it is 10. So the answer is negative 10. 3 into negative 6. Positive into negative, again negative. 3 6 are 18. Here negative 4 into negative 2. Negative into negative, the answer is positive. 4 2s are 8. Here all the answers are also integers. So integers are clause under multiplication also. Next, if you are moving to division, we can see that if a and b are two integers, then a divided by b is not defined if b is equal to 0. That is, if we have an integer a, then a divided by 0 is not defined, and 0 divided by a is equal to 0 if a is not equal to 0. Division of a number by 0 is not defined, and 0 divided by a number is 0. So, how can we conclude the closure property? Closure property satisfies only for addition, subtraction and multiplication. It does not satisfy for division. Now let us move to the commutative property. So first let us check if a and b are two integers, then a plus b is equal to b plus a using some examples. Look these two examples. Minus 5 plus 3. What is the answer of negative 5 plus 3? It is negative 2. Now let us take the reverse order, that is 3 plus minus 5. Look here, 3 plus minus 5. The answer is negative 2. In this question, negative 4 plus negative 1. The answer is negative 5. Check the reverse order. Negative 1 plus negative 4. Here also the answer is negative 5. So in these two cases, a plus b's answer and b plus a's answer both are same. So we can say integers are commutative under addition. Now let's check for subtraction. That is, a minus b is equal to b minus a or not. We can check using example. Look, here are two examples. First, a minus b, 5 minus 3. The answer is 2. The reverse order, b minus a, that is 3 minus 5. Here the answer is negative 2. This question, minus 2 minus minus 5. So to come as minus 2 plus additive inverse of negative 5 is positive 5. So 5 minus 2, the answer is 3. The reverse order, look, minus 5 minus minus 2. The answer minus 5 plus additive inverse of negative 2, it is positive 2. So the answer is negative 3. Are these two answers same? Here it is positive 2, here it is negative 2. Here it is positive 3 and here it is negative 3. So we can conclude integers are not commutative under subtraction. That is, a minus b is not equal to b minus a. Next, we can check the commutative property for multiplication. If we have two integers a and b, let us check whether a into b is equal to b into a. Let's look at examples. Here are some examples. Negative 3 into negative 2. What's the answer? Negative into negative, it is positive. 3 2s are 6. The reverse, negative 2 into negative 3. Negative 2 into negative 3, the answer is positive 6. This question, 5 into negative 4. Positive into negative, the answer is negative. 5 4s are 20. The reverse order, the negative 4 into 5, negative into positive, the answer is negative. 4 5s are 20. This question, negative 3 into 9, the answer is negative 27. The reverse order, 9 into negative 3, the answer is negative 27. Look in this all examples, a into b is equal to b into a. Here positive 6, here also positive 6. A into b, here negative 20, here also negative 20. Here negative 27, here also negative 27. So, integers are commutative under multiplication. Now, if we are moving to division, as the division of a number by 0 is not defined, we can say integers are not commutative under division. Commutative property satisfies only for addition and multiplication. Next, we can move to the next property, that is the associative property. Associative property is this: if we have three integers a, b and c. For addition, first I will say, if you have three integers a, b and c, then a plus b plus c is equal to a plus b plus c. That is, we have studied we can add integers in any order. So, let us check whether this is true. I have written here three integers, 5 plus 4 plus 3. So, first let us do a plus b plus c. That is 5 plus 4 plus 3. What is 5 plus 4? It is 9 plus 3. 9 plus 3 is 12. This side look, 5 plus 4 plus 3. Here b plus c can be joined together. 5 plus 4 plus 3. 5 plus 4 plus 3 is 7. 5 plus 7, the answer is 12. Here also 12, here also 12. So, integers are associative under addition. We now saw that we can add integers in any order. Similarly, we can multiply integers in any order. That is, a into b into c is equal to a into b into c. Let us check using examples whether this is true or not. So, here is one example, 5 into negative 2 into 3. So, first let us look is a into b into c. So, this can be joined together. Multiply and look, 5 into negative 2 into 3, it is negative 6. 5 into negative 6, it is negative 30. Now, let us check for this, a into b into c. same question. 5 into negative 2 into 3. Join these two first. 5 into negative 2, it is negative 10 into 3. The answer is negative 30. Here also negative 30, here also negative 30. So how can we conclude? The associative property for multiplication of integers. Integers are associative under multiplication. So we can conclude this associative property like this. Integers are associative only under addition and multiplication. Now we will move to the next property, that is a distributive property. Distributive property says that if we have three integers a, b and c, then a into b plus c is equal to a into b plus a into c, and a into b minus c is equal to a into b minus a into c. First we can check a into b plus c is equal to a into b plus a into c using an example. 5 into 2 plus 4. Let us do this. 5 into 2 plus 4 is 6. The answer is 30. 5, 6 are 30. Here, let us check whether a into b plus a into c is equal to a into b plus c. 5 into 2 plus 5 into 4. 5 2s are 10 plus 5 4s are 20. 10 plus 20 is 30. So here also 30, here also 30. So a into b plus c is equal to a into b plus a into c. Next we can check a into b minus c is equal to a into b minus a into c. We can write on example angle. 2 into 8 minus 3. 2 into 8 minus 3 is 5. 2 into 5 is 10. In this case, to come as 2 into 8 minus 2 into 3. 2 into 8 is 16 and 2 into 3 is 6. Here negative side minus 6. 16 minus 6, the answer is 10. Here also 10, here also 10. So, a into b minus c is equal to a into b minus a into c. Here, I am giving you some assignments what we have discussed so far. By this, I am winding up today's class. Till then, take care and be safe at home. Thank you.